Last part of this exam was some short answer and multiple choice type questions, so let's talk through those real quickly. First one, we're supposed to write the correct answer. When a falling object reaches terminal velocity, what two forces are equal in magnitude? So what we were looking for here is the fact that the weight of the object and the force of drag were equal. So we were looking for something like weight and drag force for terminal velocity. No more acceleration. Alright, which property of an object does not affect the drag force it experiences when moving through the air? So hopefully on your equation sheet you have force of drag is 1/2 rho AC sub d v squared. So we talked about these various terms. C sub d factors into the shape and the surface roughness. The velocity obviously affects it. It shows up in here, and the cross-sectional area affects it. So the only thing that doesn't affect the actual drag force is the mass of the object. That came into play if we're calculating a terminal velocity, but not the drag force. That's how you should work these problems, is just think through what we've talked about, what the equation says, and hopefully the right answer pops out. A car starts from rest and accelerates to the left. What direction is the force between the tires and the ground? Okay, so what we're looking for here, if it's accelerating to the left, that means there's got to be some net force to the left, and that net force comes from the tires and the ground. This was a little ambiguous problem. We were actually looking for the direction of the force on the tires. We said between, so I think we actually accepted just about any answer here, or actually left or right, but we were looking for left. Again, net force equals mass times acceleration. So if there's acceleration to the left, there's a net force to the left on the car. Two tug-of-war opponents each pull with a force of 100 pounds on opposite ends of the rope. What's the tension in the rope? We had this example in recitation. Okay. The key here is at any point along the rope there is 100 pounds of tension in that rope. Okay. A fly collides with a bus. Which one experiences the greater impact force? Okay, so don't get force and acceleration mixed up. The collision means that there's going to be equal and opposite forces. They're both going to be the same. Okay, what a lot of people want to say is the fly has a greater force. The fly has a much greater acceleration. The bus doesn't slow down at all. The fly gets smashed and changes directions very quickly. So huge acceleration, but the same force between the fly and the bus and the fly. Don't spend too much time on these concept questions, but do think through them, think what we've said in lecture. We're looking for basic concepts.